Hello again, my fellow new Einsteins, and welcome back to our deep dive into the furthest reaches of the periodic table. In our last episode, we explored the wild world of superheavy elements and set the stage for the next great prize in nuclear physics. Element 120, also known as Unbinilium. If you missed part 1, I highly recommend checking it out to get the full picture. The link is right down in the description. So, we know that creating these superheavy elements is like trying to hit a tiny moving target with an even tinier, faster bullet. Scientists take a heavy element, like californium, and bombard it with a lighter one, like calcium, hoping they'll fuse. But why is element 120 so special? Why are labs around the world, from Russia to Japan to Germany, racing to be the first to synthesize it? The answer lies in one of the most exciting theories in modern physics, the island of stability. Imagine the periodic table not as a flat chart, but as a landscape. Most elements we know are on a stable peninsula. As we create heavier and heavier elements, they become incredibly unstable, lasting for mere microseconds. We're essentially wading through a sea of instability. But theory predicts that beyond this sea, there's a magical island, a region where certain superheavy elements, thanks to a perfect combination of protons and neutrons, could be remarkably stable. We're not talking microseconds. We could be talking minutes, hours, days, or even thousands of years. These aren't just theoretical daydreams. The idea is based on the same principles of nuclear shell models that accurately explain the stability of common elements like lead. The island of stability is predicted to be centered around elements with magic numbers of protons and neutrons, specifically 114, 120, or 126 for protons, and 184 for neutrons. Element 120, Unbinilium, is considered a major stepping stone towards this island, or perhaps even part of its shoreline. If we can create an isotope of element 120 and find that it is even slightly more stable than its neighbors, it would be the strongest evidence yet that the island of stability is real. It would be like a sailor spotting a distant palm tree after a long, treacherous voyage across a stormy sea. So, how are scientists actually trying to do this? Let's get into the specifics of the experiments. One of the leading attempts involves bombarding a target of californium-249 with a beam of titanium-50 ions. You fire these titanium ions at nearly 10% the speed of light into a thin foil of californium. The vast majority of the time, the ions just bounce off or smash the target nucleus to bits. But every once in a while, in a fleeting quadrillionth of a second moment, the nuclei might actually fuse. It's a game of immense patience and precision. These experiments can run for months on end, generating colossal amounts of data, all in the hope of detecting just a handful of atoms of element 120. The challenge doesn't stop at fusion. Once an unbinilium atom is hypothetically created, you have to detect it before it vanishes. This is where brilliant engineering comes in. As the new superheavy atom recoils from the collision, it flies into a series of powerful magnets and detectors. This device, called a separator, works like a bouncer at an exclusive club. It filters out all the unreacted beam particles and other debris, allowing only the superheavy nucleus to pass through. Then, the lone atom implants itself into a sensitive detector, where scientists watch for its unique decay signature. Superheavy elements decay by emitting alpha particles, which have a specific energy and timing. By observing this decay chain, scientists can trace it back and prove, like a nuclear detective, that they have indeed created a new element. It's an incredibly faint signal in an ocean of noise. The race is truly global. The Riken facility in Japan, which successfully synthesized element 113 nihonium, has been a major player. The Joint Institute for Nuclear Research in Dubna, Russia, a powerhouse in superheavy element discovery, is also in the hunt. And the GS Helmholtz Center for Heavy Ion Research in Germany is constantly upgrading its equipment for the next big attempt. Each team uses slightly different projectile and target combinations, hoping their chosen recipe will be the one that works. So, What happens if we find it? What if we create element 120 and it proves the island of stability exists? Well, the implications are mind-boggling. First, it would completely rewrite our understanding of nuclear physics and the limits of matter. How big can an atom get? We simply don't know, and this would be a giant leap towards an answer. But the real excitement is in the potential properties of these stable, superheavy elements. We have no idea what their chemistry would be like. Would they be metals? Noble gases? Something else entirely? Because of relativistic effects where electrons in these massive atoms move so fast that their mass increases, their chemical behavior could be wildly different from what the standard periodic table predicts. Imagine materials with unheard of densities or novel electronic properties. While we're a long way from creating enough of these elements to hold in our hand, the pursuit itself pushes the boundaries of technology in accelerators, detectors, and data analysis. It's a quest that fuels innovation across multiple scientific fields. The hunt for Unbinilium is more than just adding another box to the periodic table. It's a fundamental exploration of the rules that govern our universe. It's a testament to human curiosity, our unyielding desire to look over the next horizon and ask, what lies beyond? We are on the cusp of potentially discovering a whole new continent of matter, one that could change science forever. Will the team at Riken, Dubna, or GSI be the first to announce this historic discovery? Or will a new contender emerge? We don't know, but we'll be watching closely. It's an exciting time to be a science enthusiast. Thank you so much for joining me on this journey to the edge of existence. What do you think we'll find on the island of stability? Let me know your thoughts in the comments below. And if you enjoyed this exploration, please give this video a thumbs up and subscribe to New Einsteins for more adventures into the amazing world of science. Stay curious, and I'll see you in the next one.